This perhaps is the most intellectually challenging part of the course. Custom actions are not trivial. Let's see if we can get you through it with as little pain as possible. Custom actions are a very powerful mechanism that allow us to write reusable Java code that can be used in multiple Java server pages. They're sometimes called custom tags. And for us to be able to write these custom actions or custom tags, what we need are three components. We need the custom actions tag to be put into the Java server page. We need a tag library descriptor that defines the tag in terms of name and attributes and so on. And we need the Java class that will be executed whenever that tag is encountered in the code. So we have then these three components: the JSP file, the tag library descriptor file, which is an XML file, and the Java file that implements that tag. And let's take a look then at the relationship between them as far as we can. We have in the Java server page, first of all up here, a tag lib, which is a directive. One of the three directives that we just haven't looked at yet because the time wasn't right. Today's the day. So we have in this tag lib directive a URI, which is the address of the tag library descriptor. And as well as that address, we have a prefix. That prefix is something that will be used within this page to indicate which library we're going to use, because we could have several of these tag lib directives within the page, and therefore we would want to identify which of the several libraries we're using by using its prefix. So whatever prefix is defined here can then be used at the beginning of the tag when we started off. So we have the angle bracket, then the prefix, colon, and then the name of the tag. So that's the beginning tag. There is a tag body, which is optional. In some tags you won't have a body, others you will. And then there's the end tag, which is written in exactly the same way as the beginning tag, but with the usual / in the second position. Now it's also possible that these tags can be designed to take attributes, in which case we would list the attributes here after the tag name and before the greater than symbol. If there is no body, then in keeping with the XML trend, we can just list the end of the tag like this in the beginning tag. So in the Java server page we can use the tag, but what happens when that tag is encountered? It works like this. The first thing that will occur is that the tag, which is listed or identified in the Java server page, will have a corresponding entry in the tag library descriptor. So that's what we're going to take a look at for a few moments. The tag library descriptor has a set of XML descriptions for each of the custom tags in the system. So that library, that one file, could describe multiple tags. And for each tag, we would record information such as the tag name, the fully qualified name of the Java class that implements that tag. In other words, it's the code that executes when the tag is encountered in the Java server page. We'll define whether the tag body has content or not, and we'll define attributes that the start tag takes, and there is other information that we might encounter in due course. So here's an example. We have the first few lines here, which are just standard. So copy those, paste them in, and then move on. We then have the tag lib tag. This is the root tag, the root element within the XML file. And so there's only one of those per TLD file. We can then define the library version, the JSP version that we're using, and the short name for the library. And then we get to the definition of the individual tags. So for each tag, there will be a tag element in this file. If you've got 3 tags in the library, then you'll have 3 repetitions of that. Of course, this bit, the name element, will have a different value for each of the tags. Here we've just got some tag. This is the name of the tag, and it's that name that will be used in the Java server page. Here we've got the tag class that's nominated, and again it's fully qualified, so we'll have the package names and then the name of the class that handles this tag. In this example, the body content is empty. The other permitted value is JSP. And then in this example, we've got one attribute. So this defines a single attribute that belongs in the tag, and therefore we would expect in the tag, whenever it's written, to have attra1 equals and then some value. We know it's called attra1 because it, that is the attribute tag, has a name element. It is required. If that's made false, then it's not required, and therefore we'd have to make sure that our tag handler is going to deal with the absence of the optional attribute. And this third part here, the RT_EXPR value, which means the runtime expression value. If that's set to true, then it will permit the Java server page to have one of the expressions. If you remember the less than %equals element, the expression element from JSP that we were talking about in the last lecture. We'll see some examples of the use of this, but it allows us then to dynamically define the value of that attribute. And if the tag is going to have multiple attributes, then there will be multiple occurrences of the attribute element in the XML file. So that's the second element. The tag library descriptor for each tag will identify the class that is going to handle the tag. In other words, it defines the code that is going to be executed whenever that tag is encountered. And so now what we are going to look at is one example, a very skeletal example of a tag handler. As well as defining its package, we have to import these things here, these packages, and then we name our class in the standard way, public class, and then some name, make it meaningful of course, so that we can identify that this class is a handler for a specified tag. Usually you'll have something like the tag name followed by handler or some other suitable word. Extends tag support. Now that immediately, through the inheritance mechanism, will make this class a tag handler. And it will allow us then to override some of the lifecycle methods and put in our own code so that it will then do what we want it to do at the appropriate points in the execution of that tag. For each attribute that is defined in the XML file, in the tag library descriptor, we will need to have a variable that matches the attribute. In addition, we'll need a set method for that attribute. So in the TLD file, if the attribute name is attra1, then we must have a method called setAttra1, because the system will look for that method and will pass the value that's defined in the tag, or defined at runtime perhaps, pass that value as the parameter, which is then used and is stored in the variable with the matching name. Now, strictly speaking, that name does not have to match the tag attribute. But if you do make it match, it at least helps to identify that this one is going to receive the value that that matching attribute in the tag has got. So if you've got 3 attributes defined in the tag library descriptor, you're going to have 3 variables here, and you're going to have 3 set methods. There's also this release method. This is quite typical in that for each of the attributes that you've defined up here, you'll set them to be equal to null, and you'll then call super.release. This is all part and parcel of freeing up this resource ready for garbage collection. Now this is where life gets a bit interesting really, because there are some lifecycle methods that are called. When the tag is first encountered, after the set methods have been called, the doStartTag method will be called, and then the doAfterBody method, and finally the doEndTag. Now doStartTag is going to be called so that you can do some pre-processing, such as validating the values of the attributes to make sure that they are suitable or within range, or they meet the business rules, or whatever it might be. And if you find any problems, then this method needs to return skip body, because that will tell the system to stop processing that tag. Otherwise, you can go on, if there is a body, to evaluate the body and include the output from that as part of the response. In this example, there is no body to process, so it's going then to not call do after body, but will straight away call do end tag. But if there is a body and you evaluate it, then do after body will be called after the tag body has been evaluated. I'll show you an example of that in a few minutes so that you can get the idea of how this all hangs together. This is where you would do any post-processing of the tag's body content. And again, you'll either skip body or return eval body again. Eval body again will essentially set up an iterative execution of the tag body. Then finally, when the tag has finished, we will then, in the do end tag, do all the post-processing of that tag, which will potentially do two things. One will be to skip the rest of the JSP page because there's been an unrecoverable problem within that tag, in which case the Java server page is aborted with an exception. Or we return eval page, which causes the Java server page or the rest of the Java server page to be evaluated, in other words, to be executed.